In this video, we're going to talk about how to actually draw the structures of organic molecules. Now, as we've said, organic molecules contain carbon, and there are a tremendous number of organic molecules out there. And because it only contains carbon, we have a shorthand way of drawing the Lewis structures for organic compounds. So rather than writing lots of carbons or C's and H's, I'm going to show you a short way or a shorthand way of actually drawing organic compounds. So the first compound I want to look at is this one right here. This compound is called butane, and butane has 4 carbons, 1, 2, 3, 4, and it has 10 hydrogens surrounding it. Now the key thing to remember about organic compounds is that every carbon has 4 bonds, and you can see that's the case here. This carbon has 1, 2, 3, 4 bonds. This one here has 1, 2, 3, 4. All these carbons have 4 bonds. Now a short way of drawing this structure is basically showing we're going to eliminate these carbons. Instead of writing them, we're just going to put them as dots or as corners of a zigzag line. And so wherever there is a corner or a change in the direction of line, that is represented by a carbon. So for a 4 carbon chain, we would draw a zigzag line with 4 points to it, where every point represents a carbon. So this point right here represents this carbon. This point here represents this carbon. This point represents this carbon, and this point represents this carbon. Now we know that carbon always has 4 bonds, and so if there is no other elements listed in the structure, we assume that all the other bonds that each carbon is a hydrogen. So this point right here is a carbon. We only have 1 bond here, so that means we have 3 hydrogens attached to that, and that's what's shown right here. Here, this point right here, we have 2 bonds, and so that means there are 2 that are not there. That represents these 2 hydrogens. And so this right here is a shorthand representation of this molecule. So rather than writing all these carbons and hydrogens, we can simply draw this zigzag line which has 4 points to it to represent the 4 carbon. Now what about another example? So let's look at this one right here. This compound has 3 carbons, so we're going to draw a line that has 3 points. So doing it next to this one, this will be point 1, that's second carbon, and that's the 3rd carbon. So this here has 3 carbons. We have 3 points here to represent those 3 carbons. Now this molecule is a little bit different because we have a double bond. So if there's a double bond in your compound, you have to represent that double bond in a shorthand notation. So notice that this double bond is between this middle carbon and the last carbon, which is this carbon here and this carbon. So we're just going to put another line to represent that double bond. And so there's only hydrogens left, and we don't need to represent the hydrogens on this. So this carbon here corresponds to this carbon. We only have 1 bond. Again, remember carbon has to have 4 bonds. So that means we have 3 hydrogens attached to this, which are represented right here. This carbon right here at this point, we have 1, 2, 3 bonds. So that means there's 1 hydrogen attached to that, which is represented right here. And this carbon here at the end, we have 2 bonds. So that means we have to have 2 hydrogens, which we show right here, but is not shown on the shorthand notation. So this right here is represented shorthand like that. Now what about this compound? This compound has 3 carbons, so again we're going to draw 2 lines which has 3 points. So each one of these points represents a carbon. This one has an OH attached to it, and that attachment is on this end carbon right here. So what we're going to do is we're going to draw a line to show that an OH is attached to that. If there's anything other than hydrogen, we have to represent it in this shorthand notation. So here we have this carbon here, only 1 bonded to it, and so that means we have 3 hydrogens, which are right here. This carbon has 2 bonds, so that means we need 2 hydrogens, which are right here. This carbon has 1 bonded to the oxygen, which is represented right here. And then we'll have 2 hydrogens, which we don't need to show on this shorthand notation. And then this hydrogen is attached to the oxygen. We do not show a line between the oxygen and the hydrogen. The only time we really show lines is whenever we're connecting carbons. So what about this example? We have 1, 2, 3 carbons again. So we draw our 3 carbon, 1, 2, 3. So every point represents a carbon. And then on the end carbon, we have a double bond oxygen. So we're going to put a double bond oxygen, and then we also have an OH. And so we will put an OH group just like that. Another example would be this one right here. Now here we have 3 carbons again. So we draw a 3 carbon chain, 1, 2, 3. And on the middle carbon, we have a double bond oxygen. And so we just simply put a double bond attached to oxygen. Now this one right here, we have 1 carbon here, so that means we have 3 hydrogens. This one has 1, 2, 3, 4 bonds, so that means we don't have any hydrogens on that carbon, and that's shown right here where there's no hydrogens. This one, we only have 1 bond, so that means we have 3 hydrogens that are understood to be there, which are represented right there. Now, what about this molecule? This is a cyclic hydrocarbon. And so we draw cyclic hydrocarbons exactly the same way. We have 1, 2, 3, 4, 5, 6. And so what we're going to do is draw a 6-sided figure, a figure that has 6 points. So 1, 2, 3, 4, 5, 6. Each one of those points represents a carbon. And the only thing left is hydrogens, and we don't need to show hydrogens on this shorthand notation. So the shorthand notation just makes it easier to draw the Lewis structures of organic compounds, because it's so much easier to draw this hexagon than it would be drawing this right here.